Thanks for sticking with us, everyone. My name is Tom, Director of Data Engineering at Business Insider. So my talk today, I was actually really thrilled to hear Steve's talk on sort of API readiness for consumption by AI agents. This is going to tackle the similar topic from a different angle, which is on data quality. So just to give a little bit more background on who we are, Business Insider, as Tara mentions, one of the biggest digital news media organizations in the world. So we're headquartered in New York. We've had an office in Belfast now coming up on 5th anniversary, I think. And so the sort of large global audience that we attract to our content is increasingly not coming from the traditional sources of like direct and referral traffic, but actually with AI and AI agents being the window into how content is consumed. And it's a fairly profound shift, I think, when you think about it. I mean, we've obviously talked a lot today about the level of the impact on the software industry. I would say that digital media, journalism, publishing is also right at the thin end of the wedge in terms of like this being a revolutionary type of moment. So whenever these systems which act as mediators into the content that's out there assemble their answers, the sources that they use are not all treated equally. You can see this example here of how it breaks down for ChatGPT. We sit in the top 10 sources here, but you can see Wikipedia by far and away outweighs all of the others. I've spent a lot of time on Reddit, kind of slightly concerning that that is in second place. And then we drop down into all of what I'm calling sites with strong domain authority and topical relevance, which is where we would sit along with a lot of our peers in the publishing industry. And in the same way that we talked about AI design needing to evolve to cope with this shifting context, actually the quality, the structural quality of our content, the metadata quality that's associated with that is increasingly important to our success in this ecosystem. Now, data quality, I think, is one thing that it's very easy to agree on as being an important thing, but it's often considered important but not necessarily urgent from a business priority point of view. And that's very definitely no longer the case for us. We recognize, I think, increasingly the criticality of that to our success as a business. And just to give a little bit of a recap around our sort of journey over the last 3 to 4 years, a lot of the focus, and this goes back to something that Dave mentioned earlier today, which is about fundamentals. A lot of the work that we've done over the last 3 to 4 years is in what I would say are fundamental or foundational things which contribute to data quality. So for example, a big challenge that we had was in trying to consolidate lots of different separate lines of reporting in our business. So you might have the editorial team or our ad revenue team deriving their own metrics from their own systems, from their own source systems directly. And what we wanted to do was gradually shift that, as like a lot of organizations do, towards a single source of truth. So building a data warehouse, which we did on Snowflake. I say we did as if that's a thing that like just happens. It took around 3 years to do, and it's kind of a never-ending task, to be honest. But establishing a data warehouse, building a single shopfront window into that through use of Looker, so trying to make data more self-serve, but really like trying to establish that consistent view across, from the executive on down, that people are looking at the same dimensions, the same metrics, they have a consistent view. And I think it's important in this context that we just talked about that unless your data model that you've built has the ability to answer the questions that the business needs, that it has the ability to derive the metrics that it needs with the right granularity. Basically, if it can't answer a question that a human analyst would ask, it's going to be unable to do any better when an agent asks the same question. So for example, building a point-in-time model of our content, so being able to say what the state of it looks like at any point in the history of a story being live, and then being able to join that with our sources of data. So all of that work, I think, pays off tremendously well, whether you're building it for humans or whether you're building it for agents or for AI systems out there in the world that are consuming our data. But the main focus of the talk that I wanted to sort of go into a little bit more detail on is this idea of trying to introduce data quality testing at scale. So again, we're dealing with some very, very large data sets. Being able to analyze those things and find issues manually is not really a scalable approach for us. So I want to talk about DBT test, and some of the tools that we use. And I guess just to give a concrete example of the type of use case that we're talking about, I'm going to use this content pairing algorithm as an example. So this is a good example because it's one case where you can very directly see an impact on revenue due to data quality issues. Essentially what this is doing, a lot of our content is consumed by news aggregation services, so think things like MSN, Yahoo, Apple News. And in this case, we have a story on the true cost of data centers on a Yahoo news feed. And within that, we want to embed relevant video or slideshow content. And for us, that drives a lot of additional revenue. It means people are more likely to view videos, click through to slideshow content that's relevant to what they're reading. So it's basically a traditional recommendation problem. And so missing events, events which are improperly tagged or categorized, all of these things hit the performance of this algorithm, and we see a direct drop in revenue from the stories that appear in these feeds as a result of that. So we will come back to this as an example. Just to kind of talk quickly about data architecture-wise, what our system looks like. As I mentioned, obviously our warehouse is Snowflake. We use Airflow, so Apache Airflow is our primary scheduler for jobs. So what tasks should run, in what order, when, so it handles the cron side of things, essentially. And dbt, which effectively is how do we transform data. So ingestion is going to vary a lot by all of the various different sources that we have, but we've put a lot of work into trying to have a consistent way of describing our business logic in our pipelines, and dbt fills that role. So dbt is essentially the T in ELT, so it's exclusively responsible for transformation. And dbt is quite a simple technology, actually, at the end of the day. It's really just SQL templates, so it's Jinja templates that use SQL. So the SQL statement here is essentially telling us what the shape of the table in Snowflake should look like, what dimensions, what measures, and then there's configuration, which tells it how the data changes over time. So in this case, it's a table. We have some information there about data contract usage, so we want this to be backward compatible. We don't want people to be able to drop columns. We want to retain those for historical compatibility. But the real secret sauce for me with dbt, and I think one of the things which we have found most beneficial from using this technology, is the metadata layer that goes alongside the SQL. So if you think about this just in source code terms, there'll be a SQL file for each model, and there'll be a YAML file. And the YAML contains this type of information here. So we're looking here at a summary based on Google Analytics 4 data for our mobile app. And what you'll get is things like plain English descriptions of all of the fields, which is very useful, obviously, across the board, really, for anyone engaging with this. And data contract information, and also things like tests, which we're going to focus on. And when it comes to our stack, as I think of it, in terms of quality testing for data, I borrow a term from sort of cloud security here, which is strength and depth, which is any one of these techniques individually does something beneficial for us, but they don't give you full coverage of all of the issues that you might have. So unit tests, fairly self-explanatory. This is the same in dbt as in pretty much any other branch of software engineering. It does the same thing for us, all the things that Dave mentioned this morning about using the tests as a way to specify the contract to your code and ensure that we don't inject defects at build time. All of that applies here. So I'm not going to touch too much on that, only other than to say that I don't think it's particularly as good as it could be. And I think you see this a lot across data frameworks, is that they lag somewhat behind in testing support. This was only added as a feature to dbt in, I think, 2024. So, it kind of gives you an idea of where the priorities are at for that. Data quality tests, though, this is where we're getting into specifically something that applies to data engineering. So a data quality test is something that is a runtime test, or as I'm calling it here, batch time. So if you imagine a job running at 10 a.m. on a Monday morning, data landing into your data warehouse, the only way to actually tell whether the state of that data is good is to actually inspect it. And that's what a data quality test does. So it's a bunch of assertions which actually run against the data in production whenever it lands into your warehouse. And the final thing then, this was something that became very apparent to us as we were building out this framework, was the need for reconciliation. So by definition, a data quality test can only test what it can actually see, what has actually arrived. It cannot pick up on things like discrepancies. If the content platform said we should have 100 post updates and we only have 99, how are we going to know that without some other sort of out of band way of checking that, either like a summary or an index or something else that we can check? So all of these three things together sort of form our overall strategy to data quality testing. And then just to talk a little bit about what a test looks like in DBT test terms, they can be as simple as this. So it can be, you can define them either at the level of your table or individual fields. In this case, we've got a composite key here, where this is basically giving us like a snapshot in time of the state of a story, the ID of the post and a timestamp. And we want to say in this particular table that that's unique and not null. Now, these tests that DBT provides are not particularly production ready out of the box. And this is one of the areas I think where there's a lot of nuance in kind of working out whether the juice is worth the squeeze, to use an Americanism I've picked up on. So what we've done in this case is we've kind of written the same test, but we've rewritten it using a package called DBT Expectations. This is a port of a framework called Great Expectations for DBT. And what we're doing here is we're constraining the test, essentially. So we're saying that we only want to check the data that has arrived in the latest partition that we've ingested into our warehouse. This is really crucial at the sort of scales that we're operating at. So to take like our Google Analytics traffic data or even our bids, like programmatic advertising data, might be like 200 billion rows in a single table. It's tens of terabytes of data. So if you imagine running a test where you're going to check that assertion against every single row in that table, it's not going to be practical. And I'd say this is another area where agentic assistance in developing these tests struggles because it doesn't have the full context about how the data is used, maybe the scale of the data. Even when it is aware of the scale of the data, I find that it also still struggles with the sort of the art of putting these tests together and understanding where the bang for buck is. And then just the final element of the stack that we have is really focused around the observability side of it. So just going back to our pipeline, we run a DBT model. So that's, again, bringing the new rows into the data warehouse. We run our tests. And then we also use a package called Elementary. And Elementary is a DBT package, so it installs fairly unobtrusively, non-invasive, as I said here. So it basically works as a hook. So your DBT model runs, your tests run, and it sort of transparently captures metrics about those things. So it'll tell you, whether your model obviously succeeded, how long it took to run, your different passes and fails of your tests, and if a test does fail, debugging information about that, which you can tune. And it writes all this back to its own schema that it owns within Snowflake. And it's from that we then derive alerts. And the alerting system that it has, I'm using Slack here as an example, but you can have various different syncs for this. What it will do is generate maybe a message like this. It'll give you a sort of summary of the test failure. We can assign different levels of ownership and routing to this. So for example, our content platform team, ad revenue team, different people who are subject matter experts in different areas will need to be engaged potentially depending on the error. And you can also include, things like I want to maybe include a sort of anonymized sample of like primary keys here, records that you can go and investigate. Now, I would say that what's increasingly becoming the case, so we talked about, obviously the shift in context around how our data is consumed out there in the world. It's also the case that the tools for observability are evolving in a similar way. So it's more that they're becoming less those sort of like alerting systems and more active participants in the process. So you can see this here with the Elementary UI in the latest version, where essentially this idea of a triage and resolution agent. Now, this is something that we're still working through. This is not something that we sort of wholeheartedly adopted, but we're kind of evaluating it. The results are somewhat mixed already. I think overall, it's probably a good thing. It definitely cuts down on the what am I looking at step. It presents information in a much nicer way. It's really when you get into the depths of the specifics of particular issues, particularly ones that go into context of outside systems where you still really have to rely on the expertise and domain knowledge of the engineer or the analyst. Datadog, who we're also a customer of, they have similar features. They recently acquired a company called Metaplane, which offers some of similar features. It's worth saying that elementary is constrained by the fact that it's obviously focused on Snowflake, DBT, and Looker primarily. So if you want lineage beyond those things into your source systems or downstream systems, you're probably better looking at something like Datadog. So yeah, that's really it. I just wanted to end on a sort of, I guess, a slightly hopeful note here, which is I think it is an urgent concern. The challenge is very great. It's becoming increasingly great for us because of the ways that our data is being consumed out there in the world. But I think with some of the tool developments that we've seen, all of what I've described was built in the the before time, when it was essentially all Google, Stack Overflow, and our own knowledge. But I do feel confident that some of these tools are definitely going to make that process more approachable. And observability, I think, is definitely absolutely essential, as is data quality. And that's all from me. Thank you very much.